Welcome back to part 2 of the trigonometry unit. In this video, I'm just going to be going over the practice problem sheet and a couple from the practice assignment. So it's mostly going to be working with degrees and radians and graphing sinusoidal waves related to them. So we're going to start with question number 1. So it says graph the function g of x equals 3 sine 2x minus 2 in radians. So for a sinusoidal wave or for a sine graph, we know that sine starts at 0. Theta or x is 0. Our y value or ratio for that is also 0. So it would usually start at the 0 point here. However, we have to do our transformations for it. So you're going to start at your 0 and you're going to times your y value by 3, so 0 times 3 is 0, and then you times your x value by 1 over 2, and 0 times 1 over 2 is 0. So then you just do your vertical shift, and you're going to bring it down too. Okay, that negative 2 is also going to be your midline, because your midline is always your k value. So I can actually just write out the values that we need to know here. So our a value is 3. Our b value is 1 over 2. Our h value is 0. And our k value is negative 2. Okay. Now, what I do for this b value, instead of having to change where my points are in, like, x value-wise, I just change all of the points that I have written down, so those points. So instead of it being at pi over 2 or 90 degrees, I'm just going to divide that by 2, so you're going to have pi over 4. Instead of pi over 2, because pi over 2 times 1 over 2 is pi over 4. Next, you'd usually have 180 degrees, or pi. You go ahead and divide that by 2, so it's pi over 2. And then the next one is usually 270 degrees, or 3 pi over 2. But you are dividing that by 2, so you're going to get 3 pi over 4. And then the last one's usually 2 pi divided by 2 is just pi. There. So that's what your new points are going to be. And now you don't have to think about the b anymore, and you just treat these points that we have written down as if it was like 90, 180, 270, 360. So usually when our sine graph is at 90 degrees, our point in the y-axis is at 1. However, we have to now apply our a value to the 1, so it's usually here, but we have to apply our a value to it. So it's now going to be at 3, which is here, and then you have to take away 2. So it is back down to here. So that's your first point. And you can check if this is right, because this a value, or the vertical stretch, should also be equal to our amplitude. So if we go up from the midline 3, 1, 2, 3, the point should be there, which it is. Now, you can do the same thing for all the other ones, or you can just do the simpler version where you just know that it's going to come back down, and then the next point's going to go down 3 away, and then it's going to come back. So you can just write it like this, or you can do it where you go through everything, so I'll show that too. So for the next point at 180 degrees, you know that the sine graph is usually at 0. Now, 3 times 0 is 0, take away 2 is down here. And then for 270 degrees, we know y is usually at negative 1, times it by 3 is negative 3, and then negative 2. It should be around here. And then when the sine graph is usually at 360 degrees, or 2 pi, the dot is usually at 0. 0 times 3 is 0, take away 2 is negative 2. So that's going to end up being here. And then you just go ahead and draw this. Make sure you're going through the points. It's hard to draw on the iPad, but make sure you can go through the points and not outside of them, but that's what the graph should look like in this case. Okay, our second question, this is number 3 in the little book. Okay, so now we have a cosine graph. So let's go ahead and write out all the values that we need to know. So we have a is 2. Our b is right here. It's the reciprocal of that, so it's 1 over 5. We have no h, but we do have a k, so k equals 2. All right. So now we know that we're working with a cosine graph, and we know that we're also going to have a horizontal stretch and a vertical stretch. Okay, For a cosine graph, we know that when x or theta is equal to 0 degrees, then our ratio for cosine of that angle is going to be 1. And that is because it is x over the hypotenuse, and x is 1, hypotenuse is 1, so it's going to end up being 1. You can also know that from the x equals cos theta. X equals cosine of 0. X is 1, so cosine of 0 equals 1. All right, so to plot this, we're going to go ahead and just start with our midline and put that at 2. Okay, just that we get that from the k value here. Okay, so we're saying that cosine usually starts at 1. We have a vertical stretch of 2. So 1 times 2 is 2. And then we have a vertical shift of plus 2. So we're going to bring this up 2. So it should start here. And now we're going to go ahead. You can always just start in by writing your radians and stuff. I find I just like to start with 0 so I know what I'm working with. So for when we usually have our 90 degrees, it is pi over 2. But we have a horizontal stretch by a factor of 1 over 5. So we're going to have to divide pi over 2 by 1 over 5. So it's going to get pi over 10. And then for 180 degrees, or pi, it's going to end up being pi over 5. 270 degrees is usually 3 pi over 2, so it's going to be 3 pi over 10. And then 2 pi over 5 is just going to be 2 pi over 5. Okay, and now we're just going to not look at our horizontal stretch and just treat each of these like it's like 90, 180, 270, 360. So when a cosine graph has an x value of 90 degrees, or pi over 2, the y value, or ratio, I suppose, is usually 0. And our vertical stretch, so 2 times 0 is 0, and then up 2. So it's going to end up being here. And then again here, if you know what a cosine graph looks like, you can just go ahead and graph all that. So you can just go like this, this, and then here. Or you can just follow along to see why that happens. Let me get rid of those. So when our cosine graph is at pi over 5, our y value is usually at -1, but we times it by 2. So it's going to be -2. And then -2 plus 2 is going to be 0. So it's going to be, it's going to be right here. Okay, and then when our graph has the x value, or theta, equal to 270 degrees, or 3 pi over 2, our point is usually at 0. And that is because the x value in 270 degrees is 0, so it would be 0 over 1, which is 0. So anyways, that's going to end up being 0. Vertical stretch applied to that, it's just going to still be 0, and then you go up 2. So it's going to be here. And then for 2 pi, it's usually at 1. And we can do our vertical stretch here. So 2 times 1 is 2, plus 2 is 4. So that's going to be somewhere there. It's hard without the lines. And then you just draw your graph like so. Okay, number 6, you can try this one out if you're confident with tan functions. If not, I'm going to give you an example. So let's go ahead and start this. Write out your A equals B equals H is 0, so we don't have to write that out. And then K is -3. Okay, let's go ahead and start. When our tan of theta, when theta is 0, tan, or the y value or ratio, is also 0. So when we do our vertical stretch to that and our horizontal stretch to that, it's just going to stay at 0. And then we just do our vertical shift, so we go down 3 units. You can also go ahead and put your midline in. Now I'm going to go ahead and do my horizontal stretches to my plotted points. So we're going to go ahead and go, this one I'm going to say is 45, this one's going to be 90. So if I'm doing that, let's start with the 90. So 90 is usually pi over 2. If we are timesing it by 3, it's going to be 3 pi over 2. And you might recognize that as 270 degrees. And we're going to have -3 pi over 2. And then for 45, 45 degrees is usually pi over 4. If we times it by 3, it's going to be 3 pi over 4. Okay, and our asymptotes are what the 90 degrees would be usually. So those just go through here and here. And now you're just going to go ahead and plot your graph. This is also the midline. Don't confuse this with an asymptote. When our tan graph is at 45 degrees, our y value is usually at 1, but we have a vertical stretch, so it's going to be at 2, and then we take away 3. So it's going to be right here. You can't really see it, but you know it's there. And then when our tan graph is at negative 45 degrees, or negative pi over 4, is usually at negative 1, times it by 2, it's negative 2, and then you have your vertical shift of negative 3. That should be somewhere there. There we go. And then you just go ahead, flatten out near the middle, and then go back up. Your graph will look neater. It's just hard to show it neatly on this. Okay, next question. We have another graphing problem. This one is a sine graph, so you can go ahead and try this. If not, I'll work through it. So this one we actually have an h value, so there is a phase shift. So let's go ahead and write out everything that matters. Okay, actually first what we're going to do here is factor this out so we can actually get the correct phase shift. So for that, you just do your pi over 4 and then times it by x, take away, and then you just divide 3 pi over 2 by pi over 4. So that's going to end up being 12 pi over 2 pi. The pi's cancel out, and it's going to end up being 6. So it's actually going to be negative 6. There we go. If you're wondering how I did that, you basically, if you're doing 3 pi over 2 divided by pi over 4, you can actually just flip. If you change this to a multiplication, you can flip this into its reciprocal. So this is going to be equal to negative 3 pi over 2 times 4 over pi. And then how you do that is you cancel these out. And then you just have 4 times your 3, which is 12, over 2. And then 12 over 2 is 6. So that's how you get that. So anyways, now we have our h value and we have our b value. So b is going to be a reciprocal of that, so it's 4 over pi. And our h value is 6 because it has a negative here, and we do the opposite of that, so it's positive 6. And then for k, we have plus 2. Okay, we have everything we need to graph here. So I'm just going to start by actually writing out my degrees. So we know that we have 0 here. And I'm going to go over by 2's, so this is where my 90 degrees is going to be. So 90 degrees is pi over 2. If we times pi over 2 by 4 over pi, then the pi's cancel out, and we get 4 over 2, which is 2. So you can just do 2. And then we know that 180 degrees is just 2 times 90. So we know that it's just going to be 4. Same for 270, it's just 3 times 90, so it's going to be 6. So we know we're just going up by 2's each time. So you can just do that, or you can do the math for every single one. It's just going to take more time. Okay, now we're going to start by plotting. So at 0 degrees, a sine graph is usually at 0. Times that by the vertical stretch of 3, it's 0. And we're going to go over 6 in the x axis and up 2. So it's going to be, first point is going to be here. We can also draw in our midline. We know that our k value is plus 2, so we know our midline is at plus 2. There we go. And now we can do our second point. When when theta is 90 degrees, the y value or ratio is usually at 1. Times that by 3, it's 3. Add 2, and then go over 6. That's where your second point is going to be. To make sure that's right, you want your amplitude to be 3, so this should be 3 away from the midline. 1, 2, 3. Yeah, so that's right. Okay, for the next one, when this is 180, when theta is 180, our point is usually at 0. Times that by 3, it's 0. Add 2, and go over 6. That should be right there. And then for the next point, when theta is 270. The point is usually at -1. You want to go up 2 and over 6. So that's going to be, oh, accidentally put that the wrong point. That's going to be over here. Okay, and then for the last point, when theta is 360, it's going to be at 0. You're going to go up 2 and over 6. Okay, and I actually have to put in 14 here. I actually forgot that. Okay, so that's what your graph's going to be. If you want to make sure it's right, you just check the amplitude. This is 1, 2, 3, and the other one is 3 as well. So you know that this is going to be right. So you just go ahead and draw your line. So that's what it will look like. Okay, next question. You can try this one by yourself. Write in everything. We're going to actually have to factor this one as well. I think it's going to be the exact same thing, but we can check. Negative 3 pi over 2 times 4 over pi is going to be -6. So yeah, it's the exact same. B is going to be 4 over pi. H is 6 because it's the opposite of negative, and then K is 1. So now we have a cosine graph, and we also have a negative vertical stretch. Cosine graph, let's go ahead and write our midline for that. So our K value is at +1. So you can go ahead and draw your midline at +1. Okay. Now we're going to go ahead and start graphing. So when it's at 0, it's usually at 1. We're going to times that by -2, so it's -2. We're going to go over 6 and up 1. So the reason why I was able to just go over 6 here is because it's the same as the last graph. So we know it's going to be 2, 4, 6, 8, 10, 12, 14. It's just all the same numbers because our horizontal stretch is the same. You should always write in like your values first, because for example, if you didn't go over by 2 each time, this 6 would actually be right here, because it would be 2, 4, 6. So you just have to make sure that you write in those values first so that you don't mess up where everything's meant to go. So that's the first point. Now, in a cosine graph, when our theta is 90 degrees, usually the point is at 0, but we have to go up 1 and over 6. So it's going to be here. Usually when it's at 200 or at 180, we're at -1 times that by -2 is going to be 2. Go up 1 and over 6. So that's going to be here. And then when it's at 270, it's usually at 0, but we have to go up 1 and over 6. So that's going to be here. And then when it's at 360, it's usually at 1, but we have to times it by -2, so we're going to get -2, and then go up 1 over 6. So that's going to be here. You can check your amplitudes to make sure that they go up by 2 each time, because the amplitude is the absolute value of whatever your stretch is. The negative just tells you if it's like going to be reflected. So this should go up 2, which it does, and this should be down 2, which it is, and this should be down 2, which it is. So all of that is right. Now you can go ahead and draw your curve like so. Okay, 12. You can go ahead and try this one by yourself. I'm just going to start writing everything in. I'm going to start by doing my midline, which is through -3. And now I'm going to go ahead and write in, it's a tan, so we know that the period is usually 180 degrees. So I am going to write that in. So I'm going to say that here is 90 and here is 45, just so that there's more room to see what I'm doing. We actually have to factor this first. I didn't realize it wasn't factored. So let's do pi over 12 times x negative. Okay, and now we do pi over 4 times 12 over pi. The pi's will cancel out, and then you're left with 12 over 4, which is just 3. There. So our b value is 12 over pi, and our h value is positive 3. So pi over 2 times 12 over pi, the pi's will cancel out, you get 12 over 2, you're going to have 6, and negative 6 there. And then the 45 is just half. I mean, you can do the math for it, but it's just half of 90, so this is going to be 3. This is going to be negative 3. So let's write our asymptotes. Okay, so that's what the graph would usually be with, but you have to take into account that you have a phase shift. So when you have a phase shift, it moves not only the points, but also the asymptotes. So here, let me just add in 9, and I guess I put negative 9 where I use it, but I'll put it in. So this means that our phase shift, or that our asymptotes are also going to move over 3. So instead of being at 6 and negative 6, it's going to be at 9 and negative 3. There. Now we can go ahead and write in our points. When theta is usually 0, our ratio is usually 0, but we have to go down for our vertical shift, we go down 3. And then for our phase shift, we go over 3. So that's going to be here. Make sure you don't go over like 1, 2, 3, because that's actually going in between 3 and 6, which is right here. So it'd actually be going over 4.5. You have to make sure to watch how you have your graphs labeled. So for right here, it's 3. So you go 3. Next, when you have 45 degrees, it's usually, the ratio is usually 1. But we have to do our vertical stretch of 3, so it's going to be at 3. And then you go ahead and take away 3, and you go over 3. So that's going to end up being here, instead of usually being like here. Because you have to go over 3, just make sure you're watching how you have your graphs labeled. You can check this by making sure that the amplitude from the midline to that point is 3. 1, 2, 3, it is, so you know it's going to be right. And then for the next one, at negative 45, it's usually negative 1. Times that by 3, it is negative 3. And then you're going to go over 3 and down 3, which is going to be there. And then you just connect it. Okay, now we're going to be determining equations of functions, of graphed functions, and indicating the phase shift. We're going to indicate the phase shift for this one in degrees, just to change it up a bit, and then the next one I'll do in radians. So determine the equation of cosine function graph below. So let's go ahead and just write everything out that we have to know. We need to know A, B, H, and K. And we need this to answer our equation, which is y equals a cos of bx negative h plus k. So that's all the information we need. We need a, b, h, and k. I like to start with my h and k because it's easy to see by the way that this y-axis is moved over and the midline is moved down. So we can start with that. So our midline was moved down 1, 2, 3. So we know our k is negative 3. And our y-axis was moved over 1. So we know that it is negative 1. But when we write it in the equation, it has to be positive 1 because we have the negative sign here. So it flips the sign. Okay. And then for A, you just want to check what the amplitude is. Usually it's 1, but here we can see that it's 2. So A equals 2, but you also have to see that this is negative because usually cosine starts in the positive and goes down like so. So we know that it's also negative 2. So you can go ahead and do that. Make sure you're watching out to see if it is flipped because sometimes it doesn't look like it right away because there's multiple periods here. So sometimes it doesn't look like it's flipped, but it is. Okay, and then for B, you just count what the period is, and then you divide it by what the period's meant to be. So for here, we see that it goes over 1, 2, 3, 4, 5, 6, 7, 8. It goes over 8, and we know it goes over 8 because each of these little dashes are just representing 1. So you do 8, and then the period for a cosine graph is usually 360, so you put it over 360. And this is going to simplify to 1 over 45. So our b value is 1 over 45, but when you put it into the equation, you have to do the reciprocal. So it's going to end up being 45. And that is 45 degrees it represents. So we would write that as in radians. We would just do it as pi over 4, but this one specifically I'm doing in degrees. So now we can fill everything in. Y equals -2 cosine, and then we do our b value, which is going to be 45, x, and then -1, so +1. Oh, you actually need a bracket there, whoops. And then plus k, so -3. And this is your equation for that. Okay, next one we have a sine function. I get you to do this one in radians, just so you know how to do radians and degrees. So let's start by writing out everything that we need to know. Okay, let's start by finding h and k. So our midline has gone up 1, and our h has gone over 1, 2, 3. So 3 in the equation is going to be -3 though. And then for a, we can see that our amplitude is 1, 2, 3, 4. It's 4, and our graph is going down and then up instead of up and then down, so it's negative. So we know it's going to be -4. And then b is going over 1, 2, 3, 4. So we have 4 over 360, which is going to be 1 over 90, which is going to be 90 when we write our equation. So now let's just fill everything in. Y equals -4. Sine, remember to put your sine or cosine. Okay, and then sine of 90, oh, sorry. I literally just said we're doing this one in radians, I did in degrees. So to get your radians, you know that it's 90 degrees, and you know that 90 degrees is pi over 2. And you can also just do that by doing 90 times 180, pi over 180. And this is going to cancel out to be 1. And this is going to be 2. And that's just going to equal pi over 2. So that's how you get that. So you do pi over 2 times x -3 plus 1. And that is your equation for that. Okay, 17, this is the last graph one, and I think there's 2 conversion ones, so you can go ahead and do this. Also, all of these should have been without a calculator. The next two you can use a calculator, but these ones should all be without a calculator. Okay, you can go ahead and try that. So let's write out everything we need. Let's start with h and k. We can see that our point has been moved over 1, 2, 3, 4. So this is -4 in the equation. And then we can see that our midline has been brought down 1, 2, 3. So this is -3. And then a, we can see that instead of going up 1, this goes up 2. So a is 2. And b, we can see that this goes 1, 2, 3, 4, 5, 6. So we have 6 over 180 because the period for a tan graph is 180 and not 360. So this is going to end up giving us 1 over 30, which you can put here, which is 30 in the graph. To do this in radians, you just convert 30 degrees to radians, which is going to be pi over 6. So you can write it using this or this, but for this one, I'm just going to do degrees. So the equation for this is y equals 2 tan 30 times x plus 4 -3. And that's your equation there. Okay, these last 2 questions you can use your calculator for. So we're converting degrees to radians. So to convert, this is kind of like if you took stoichiometry in chemistry. This is kind of the same idea. Or like in physics when you convert from like meters to kilometers and stuff like that. It's the same idea. So when you have 2,475 and you want to convert it to radians, you just put your degrees on the bottom and the degrees will cancel out, and you put your radians on top, which is pi. And you just divide the 247, or sorry, 2,000, I don't know why I said 247, 2,475, you divide it by 180, which you get 13.75, and then you just times that by pi. So you get 43 point, and it says 2 decimal places. You would get 19, but you're going to get 20. And remember to say that that's radians. So that's the answer for that. Okay, last question. It says convert radians to degrees. So this is going to basically be the opposite of the other one. So we're going to have our 77.6 radians, and we're timesing it. In this case, you want to put your radians on the bottom. So you're putting the pi on the bottom, 180 on the top, because if there was like rad here, they cancel out, and you're left with degrees. So you're going to divide your 77.6 by pi, and then you times it by 180. And this is going to give you 4,446 degrees. And it's just 4,446 because you round to the nearest degree. And that's just how you do that. All right, that is the end of this video, part 2 of trigonometry. If you want me to do anything else, or you have any other examples you want me to do, just let me know. And if you have any questions, let me know. Hopefully this helped, and hopefully you enjoyed.